Hey guys, here's another video. We're still in the same section. We're still going to be practicing these trig identities because again, you're not going to get any better at these if you are not just doing a lot of practice. So I'm going to do a couple problems that came out of the last assignment, ones that I feel like were probably more difficult than some of the others. So I'm going to do 35 first. So 35 is the tangent of theta plus the cotangent of theta equals secant of theta times cosecant of theta. So again, I want to choose which side I want to work with, either the right hand side or the left hand side. And this problem probably really doesn't matter. I think I'd like to work on the left-hand side. And again, my thought process is, well, on the left-hand side, I have two terms. On the right-hand side, I have one term. And usually for me, I find it's usually pretty easy to go from two terms to one, especially in the case here where I have tangent and I have cotangent. I know I can rewrite tangent as a fraction and I can rewrite cotangent as a fraction. And if I have a fraction and I want to combine them into one fraction, I know it simply requires finding common denominators. So I see that, so that's my thought process. So again, that's what I'm going to work with. I'm going to work with the left-hand side. So on the left-hand side, I have tangent of theta. I can rewrite that as sine of theta over the cosine of theta. Plus, on the right-hand side, or sorry, not on the right-hand side, but this cotangent, I can rewrite that as cosine theta over sine theta. So now I have a fraction plus a fraction. Well, if I have a fraction plus a fraction, I simply need to make common denominators. I have cosine here and I have sine there, so clearly the common denominator is simply cosine times sine. So this fraction here needs a factor of sine theta over sine theta. So I would get sine theta over sine theta times the sine theta cosine theta that was already there. I have cosine theta over sine theta. This had cosine already, so it needed the sine. This already has sine, so it needs the cosine. So I need to multiply by cosine of theta over the cosine of theta. So if I multiply this out, on top I get sine theta times sine theta. That is sine squared theta. In the denominator I have sine theta cosine theta. Plus here I have cosine theta times cosine theta. That's cosine squared theta. And then I have sine theta cosine theta. Now that I have common denominators, I can add those two fractions together. I can write it as one fraction. So this is all over sine theta cosine theta. And on top I'll get sine squared theta plus cosine squared theta. So sine squared theta plus cosine squared theta, we should recognize that at this point that's just equal to 1. So I get 1 over sine of theta cosine of theta. Well, 1 over sine theta, that's just cosecant of theta. And 1 over cosine theta, that's just equal to secant of theta. So this expression is really the same thing as secant of theta cosecant of theta. Okay, so like I said, that was number 35. I'm going to do a couple more out of that assignment, and then we're going to move on to some other ones that you haven't even attempted yet. Before I move on, though, I wanted to talk about a couple of things. First, moving forward, if you notice on Aries, I'm no longer going to be assigning the odd problems. I've had a handful of people email me their assignments that they've done, and very clearly I can see they just copied the answers out of the back of the book. So if you're at home watching this and you're wondering why all of a sudden I switched on Aries to assigning even problems as opposed to odd, well, like I said, I have too many people that are just trying to get homework credit. They're not doing the problems, they're simply copying out of the back of the book. I can tell because what's in the back of the book is not what I'm showing here. There's different notation, there's certain things that are really pretty good indicators that these people are just, like I said, copying down answers. So to curtail that, from here on out, you're going to get the evens. Sorry, you won't be able to check your answers in the back of the book anymore. If you get stuck on a problem, you can email me and I can help you figure it out. Additionally, some of your guys' homework is coming to me, and while it looks like you're legitimately doing it, it's also not following my format here. If I'm working on the left-hand side or if I'm working on the right-hand side, it's very apparent. Here I'm working on the left-hand side, so I can see all of this work on the left-hand side, and then I have my equal signs right here, and this remains untouched. Some of you are not following this format. Some of you are just writing horizontally and just stretching, and it just doesn't make a whole lot of sense. Okay, please stop doing that. The way I'm modeling it here on the video is the way you should be doing these problems. Okay, notation-wise, organization-wise, I'm using the left-hand side or I'm using the right-hand side, so what I expect in your work that you're turning into me, I expect it to look the way I'm presenting it here. Okay, do not write horizontally. That's not how you're going to go about proving these identities. So, having said all that, let's move on. I'm going to do number 39. Again, this is out of the last assignment. So if you have not done the last assignment yet, I'd appreciate it if you try to do 39 first or 35 first, whatever problems I do here in this video. And then if you get stuck, refer back to this video to try to do those. So on 39, I have sine x plus cosine x squared over sine squared x minus cosine squared x. On the other side, I have sine squared x minus cosine squared x all over sine of x minus cosine of x squared. Okay, well, both of these sides are almost identical. They're not quite reciprocals of each other, but they're very similar. So working on the left-hand side or the right-hand side, probably going to result in the same number of steps roughly. So it doesn't really matter. I think I'll probably stick with the left-hand side, just especially, if I'm making this video. If I'm trying to work on the right-hand side too much, then I'm going to be covering up a lot of the board because I'm right-handed and I'll be standing in front of the board. So just really, it's a toss-up here. I'm just going to go ahead and use the left-hand side. So on the left-hand side on top, I have sine x plus cosine x squared. Well, sine x plus cosine x squared, that's the same thing as sine x plus cosine x times sine x plus cosine x. Right? That's what it means to have a quantity squared. It means multiply it times itself. So all I did was I just expanded the top. In the denominator, I have sine squared x minus cosine squared x. Well, first things first, don't look at that and say, oh, I have sine squared minus cosine squared. That must equal -1 or something like that. Remember, we know the Pythagorean identity. The Pythagorean identity is sine squared x plus cosine squared x, so that equals 1. But if this suddenly becomes a minus sign, that doesn't just simply make that a negative any more than if I had 7 plus 4 equals 11. If I suddenly turn that into a negative sign, 7 minus 4 does not equal -11. Now I'm bringing this up just because my experience tells me that sometimes students will see something like this and recognize this as being some of the terms that we see in our Pythagorean identity and think, oh, because that sign switched, I must just switch the sign. Well, that doesn't make any sense, so please don't do that. Sine squared x minus cosine squared x is not an identity, okay? It's not the Pythagorean identity. It's not some manipulation of it. It does not equal -1 or anything like that. But what it is, it's a difference of two squares. This is a squared minus b squared. So if I want to factor a difference of two squares, that factors to be a plus b times a minus b. And if I do that, well, now I have a bunch of stuff factored out, and I can see right here, oh, those two factors are the same. They can divide out. So now all I have left is sine of x plus cosine of x over sine of x minus cosine of x. So right now I have sine of x plus cosine of x over sine of x minus cosine of x. Is that what we're trying to get? No, I'm trying to get this expression over here. What I'd like is sine squared x minus cosine squared x on top. Well, right now I have sine x plus cosine x. Well, how would I get a difference of two squares here? Let me go ahead and erase this equal sign. Well, how would I get a difference of two squares? If I already have the a plus b part, then I need the a minus b part. Now I'm only allowed to multiply by a factor of 1 to not change the expression's value. But if I multiply this now by the conjugate, which is sine of x minus the cosine of x on both the top and the bottom, well, I'm multiplying by a form of 1, but if I do that, what it's going to get me on top, I have a plus b times a minus b. That's a difference of two squares. That simply becomes sine squared x minus cosine squared x. And in the denominator, I have sine of x minus cosine of x times sine of x minus cosine of x. If I'm multiplying something times itself, well, that is the same thing as having that binomial squared there. And is this what I was trying to get? Yes, that's exactly what I was trying to get. So if you were stuck at all on 39, that's all there was to it. If you worked on the right-hand side, I'm sure the steps would be very similar ideas. Okay. I'm going to do one more from the assignment. I'm going to look at number 43. And then, like I said, I'm going to move on and do some more further on in the section. After I film these videos and then I upload them to YouTube, they typically take several hours to upload to YouTube because these videos end up being about an hour long. They usually wind up being between 6 and 7 gigabytes, and so that takes several hours to upload to YouTube. As soon as it uploads to YouTube, I'll add the assignment that corresponds to this on Aries. Again, please make sure you're formatting things correctly. Okay, number 43. I have 1 over 1 minus sine squared y. And that's supposed to be equal to 1 plus tangent squared y. So, again, choosing between the left-hand side or the right-hand side. If I do the right-hand side, wouldn't be too bad. If I do the left-hand side, it still wouldn't be too bad. Again, this is really just kind of a toss-up, but because of me videotaping and stuff, I'm probably just going to stick with the left-hand side here, just so I'm not really standing in the way too much. So when I look at the left-hand side, well, what I see is I see 1 minus sine squared in the denominator, and at this point, if you've been following along the videos and if you've been actively trying to do these on your own, at this point you probably recognize that 1 minus sine squared is really just cosine squared. So this becomes 1 over cosine squared y. And 1 over cosine squared y, well, cosine is the reciprocal of secant, so 1 over cosine squared y is the same thing as secant squared y. Well, secant squared y is not what it is that I'm trying to get on the other side. However, I have secant squared y, and I'm trying to equal 1 plus tangent squared y. Well, that's one of our Pythagorean identities. I know, just from our notes, that secant squared y is exactly equal to 1 plus tangent squared y. This is just an identity from our notes. Therefore, this is equal to that, and now I can stop. Okay, so if you got stuck on any of those, that's all there was to it. If, as you're doing any of these assignments, you get stuck on any problem, I already had a couple students do it to me today. They got stuck on a problem, and they just sent me a picture of what they had done so far, and I was very quickly able to just kind of diagnose what it is they had done wrong, or gave them a suggestion as what they might still do, and within a couple of minutes they were able to complete the problem. So you're only going to get better at these by struggling with them and actually trying. Don't just write stuff down just because you want a couple of extra credit points. Really actively try on these, because next year in calculus it's going to be very apparent who really knows their trig and who does not. Okay, so moving on, I'm going to do some more out of the textbook. So I have 1 minus cosine x over sine x. That's supposedly equal to sine of x over 1 plus cosine x. So again, this is another problem where both sides look about the same as far as complexity. So I'm really able to do whichever one I want, whichever side I want. Again, I'm probably going to stick with the left-hand side as much as I can, so that way the video shoots better. So, everything's already in terms of sine and cosine. I don't see any identities jumping out. Be careful, 1 minus cosine does not equal sine. 1 minus cosine squared would equal sine squared, but 1 minus cosine itself is not equal to sine. So please don't make that mistake. But what I want to do is I want to somehow go from 1 minus cosine to just simply having a sine here. And I am aware that 1 minus cosine squared would give me a sine squared. So that's kind of where I'm thinking here is, well, if I could somehow get this to be 1 minus cosine squared, well, I can accomplish that by multiplying by the conjugate, okay? So if I multiply by the conjugate of 1 minus cosine x, that would be 1 plus cosine x. But again, I'm only allowed to multiply by a form of 1. That way I'm not changing the value of this expression. So this is what we started with. Ultimately, I want a sine on top. I can get close. If I can turn this into 1 minus cosine squared, then I know I can replace that with sine squared x, and that'll get me a little bit closer to sine x. And the only way I'm going to get this to be 1 minus cosine x is if I multiply it by the conjugate, which is 1 plus cosine x, because now I would have a plus b times a minus b, which would give me that difference of two squares. So on top, if I multiply this out, 1 plus cosine x times 1 minus cosine x is in fact the difference of two squares. 1 minus cosine squared x. In the denominator, well, I have 1 plus cosine x times sine x, and like I've told you on previous problems, it's not a good idea to multiply that out. It's a better idea just to leave it factored. So I'm going to leave this as 1 plus cosine of x times the sine of x. Well, don't forget, why did we want to create 1 minus cosine squared here to begin with? We wanted 1 minus cosine squared because ultimately I want to get a sine on top. And I know that 1 minus cosine squared is equal to sine squared x. So now I'm going to make that substitution. So I have sine squared x over 1 plus cosine of x times sine of x. And again, we left the denominator factored because when you leave it factored, if there's any factors that can cancel, you'll already be in factored form and you can readily cancel those factors out. And in fact, I have two factors of sine on top, right? Sine squared is really sine x times sine x. So one of these factors of sine is going to cancel out with one of those factors of sine, or that only factor of sine. And so when I cancel this out with one of the factors of sine here, I wind up with sine x over 1 plus cosine x. And that's exactly what I was trying to get. Okay. By the way, I appreciate those of you who are completing the assignments, even though you already have an A in the class. It's not like you need the extra credit, you already have an A. But I really do appreciate those of you who are just doing it for the sake of knowing how to do this, as opposed to just taking your A and calling it a year. Okay, let's look at the next problem. Tangent squared theta minus sine squared theta. And that's supposed to be equal to tangent squared theta times sine squared theta. So let's show that this is true. Now again, this probably means, or this, the looks of this probably is easiest, on either side. Whether I work with the left-hand side or the right-hand side, probably take a similar number of steps. Again, I'll probably just work with the left-hand side because of the video, like I've explained. And besides that, I do have a preference towards, a lot of times if I have two terms, over here I only have one term, I have a preference towards trying to turn two terms into one term as opposed to trying to take one term and turning it back into two terms. I mean, either way is not too bad, but it's my preference. So anyhow, I have tangent squared minus sine squared. That's not any trig identity, not the one that we have in our notes. So another thing we may fall back on is, okay, let's turn things into sine and cosine like we typically do. So if I turn tangent squared theta into terms of sine and cosine, that becomes sine squared theta over cosine squared theta, and over here I still have sine squared theta. Sine squared theta is the same thing as sine squared theta over 1. I'm putting it over 1 simply because, well, I have this fraction, and if I make that a fraction, I can see that, probably the step here would be to make common denominators. So the common denominator between cosine squared and 1 is obviously cosine squared. So this fraction will remain unchanged, sine squared theta over cosine squared theta minus, here I have sine squared theta over 1, but it needs a factor of cosine squared theta in the denominator. So I'll multiply by my form of 1 cosine squared theta. Now if I simplify this fraction is still sine squared theta over cosine squared theta minus, well, if I multiply this out, I get sine squared theta cosine squared theta over cosine squared theta. Now that I have common denominators, I can write this as one fraction. So this is all over cosine squared theta. On top I have sine squared theta minus sine squared theta times cosine squared theta. So this is sine squared theta minus sine squared theta cosine squared theta. Well, that's not what I'm trying to get. I'm trying to get just tangent squared times sine squared. Let's see what we can do. So now I'm looking on top. I have two terms. I have the sine squared theta term, and then I have this larger term of sine squared theta times cosine squared theta. Well, they have something in common. They have a greatest common factor of sine squared theta. So maybe I can factor that out. Maybe that'll take me somewhere. So if I factor out the greatest common factor on top, sine squared theta, let's see what's left. If I had sine squared theta and I factor it out, it leaves me with 1. Minus, from this term, if I factor out the sine squared theta, I still have the cosine squared theta. And then the denominator, I have cosine squared theta. Well, from here, I factored, nothing cancels. However, now that I have this 1 minus cosine squared theta, well, I know what 1 minus cosine squared theta is equal to. It's equal to sine squared theta. So let's make that substitution and see what I have now. I have sine squared theta, which is what I already had. This is also another sine squared theta over cosine squared theta. Well, again, sometimes you want to kind of take a peek at what it is you're trying to get. I'm trying to get this. How close am I? Well, what is sine over cosine? Sine over cosine is tangent. So what's sine squared over cosine squared? Isn't that tangent squared? So this portion right here, that's tangent squared. And what's left? Sine squared, which is exactly what I want. So we're one step away. We just need to write our final result, which is tangent squared theta, sine squared theta, and we're done. look at this problem. Sine of x minus 1 over sine of x plus 1. That's supposed to be equal to negative cosine squared x over sine x plus 1 squared. So, probably work on the left-hand side. On the left-hand side, I have sine of x minus 1, sine of x plus 1. They're already in terms of sine and cosine. There's no identities that are jumping out at me that I could substitute with. This is what I have on top of this fraction right now. This is ultimately what I want. Well, ignore the negative sign for a second. I'd like a cosine squared x on top. Here I have a sine x minus 1. Well, how would I get cosine squared x? I can get a cosine squared x by having a 1 minus sine squared x. Because again, that's the Pythagorean identity. So if I can somehow manipulate this to be 1 minus sine squared x, I can replace that with cosine squared x. Well, right now I have sine x minus 1. How could I possibly get sine squared? Again, we're only allowed to work with one side of the equation, so it's not like I can just like square one side of the equation or square both sides, because we're not working with both sides. We're simply working with one side or the other, so my options are, if I don't want to change the value of the expression here, I'm only allowed to multiply by 1 or add 0. Those are our options. Okay? So, well, if I have sine x minus 1, if I multiply by the conjugate, sine x plus 1, it'll create a difference of 2 squares on top. So that's what I'm going to do. I'm going to multiply the top and bottom by sine x plus 1 over sine x plus 1. So again, I'm just multiplying by a form of 1, so that way I'm not changing the value of this expression. I'm simply changing the way that it looks. So on top, if I multiply this out, sine x plus 1 times sine x minus 1, that's a difference of 2 squares. That's a plus b times a minus b. So if I multiply that out, I get my difference of 2 squares, sine squared x minus 1. In the denominator, I have sine x plus 1 times sine x plus 1. Well, if I'm multiplying something times itself, again, that's just that quantity squared. And if I look already at what we're trying to get, this is what I have in the denominator, and that's exactly what I want in the denominator. So the denominator is taken care of. Now I just need to continue to work on the numerator. If I work on the numerator, I want to get that. Now again, what we talked about is cosine squared is equal to 1 minus sine squared. I don't have 1 minus sine squared. I have sine squared minus 1. So if you think, well, how can I take sine squared x minus 1 and make it 1 minus sine squared x? Well, that's simple. We do it a lot. You can factor out a negative 1. So if I factor out a negative 1 on top, this sine squared becomes negative sine squared x, and this negative 1 becomes positive 1. In the denominator, I still have sine x plus 1 squared. And if I look at this, negative sine squared x plus 1, well, that's no different than saying 1 minus sine squared x. And again, what is 1 minus sine squared x? It's really just cosine squared x. So I would get negative 1 times cosine squared x. That's negative cosine squared x. In the denominator, I have sine x plus 1 squared. Okay. That's exactly what I wanted to get, and that's what I have. So, look at another problem. This time I have sine of t plus cosine of t. sine of t, cosine of t. So I have sine of t plus cosine of t squared over sine of t cosine of t. That's supposed to be equal to 2 plus secant of t times the cosecant of t. Well, I think the left-hand side looks more complicated. It gives me more to do. Namely, I can multiply that out. So sine of t plus cosine of t squared, that's simply a plus b squared. A plus b squared multiplies out to be a squared, in this case sine squared, plus 2ab, so 2 sine cosine, so 2 sine of t cosine of t, plus b squared, so plus cosine squared t. In the denominator, I just have sine of t cosine of t. Well, on top now I see that I have a sine squared t and a cosine squared t. Sine squared t plus cosine squared t, we know that's the identity, that's just 1. So this is really 1 plus 2 sine of t cosine of t over sine of t cosine of t. Well, as tempting as it may be, don't forget I cannot cancel out this term with this term, right? If they were factors, I could cancel them out, but this is 1 plus this. It's not 1 times that or anything like that. It's not factored. So if it's not factored, don't just cross that off. 1, if you did that, if I cross this off with this, what would I get? I just get 3. Is 3 going to somehow become that? No, it's not correct. Okay? However, and I did it in a couple problems yesterday, we have this one fraction. This is just one giant fraction here. What I really want is 2 terms here. I have this term and I have this term. And so much like we did on a couple problems in the last video is I can split this into 2 fractions. This is the same thing as 1 over sine of t cosine of t plus 2 sine of t cosine of t over sine of t cosine of t. So I just split the fraction up. The denominator is the same on both of these. It's the same denominator that I had. I put this term on top of this fraction, the other term on top of the other fraction. I mean, if you think about going backwards, if I was trying to go backwards, I have common denominators. If I was going the other direction, I could add these together and it would be simply that fraction. I just split the fraction apart. But if I do that, let's think about what we have here. Now, this sine t cosine t would cancel out with that sine t cosine t, leaving me with just what? A 2. Well, that's what I want. I want a 2. Plus, well, here I have 1 over sine cosine. Well, 1 over sine, that's just cosecant. 1 over cosine, that's just secant. So at this point, I already have what it is I want. And now we're finished with that. Okay, again, the more you do these, the more you struggle with these, you'll see some common things that you may try. The more you do them, the more experience you get, the better you're going to get at these. Just like with any other problems, whether it's factoring or solving equations or whatever, the more experience, the more different types you see, the more approaches you have in your toolbox with which to kind of approach these problems. Okay, this next problem I have 1 plus tangent squared u over 1 minus tangent squared u. And that's supposed to equal 1 over cosine squared u minus sine squared u. So, again, both sides are fairly complex. Doesn't really matter which side I use, but again, I'm probably going to use the left-hand side. I do think the left-hand side presents a little bit more to work with. The right-hand side, I mean, there's not a whole lot I can do with the 1 here. And besides that, cosine squared minus sine squared is not an identity. Well, not one that you know. I know what it is, but that'll come up later. Okay, so on the left-hand side, if I'm looking at this fraction, I have a 1 plus tangent squared, and I actually do know what that is. 1 plus tangent squared, that's one of our Pythagorean identities. that's really equal to secant squared u. In the denominator, I still have 1 minus tangent squared u. Well, now I've used the one identity that I know. 1 minus tangent squared. Again, don't see parts of an identity and think, oh, it's slightly different, so I'll just slightly change the other side of the equation. 1 minus tangent squared does not equal, for instance, negative secant squared or anything like that. So make sure, before you substitute, make sure you know for sure if you have a valid substitution. Remember, the Pythagorean identity we have is 1 plus tangent squared u equals secant squared u. So I replaced 1 plus tangent squared u with secant squared u. But, well, I don't have anything that tells me I can do 1 minus tangent squared and equal something. Okay, this isn't 1 minus tangent squared, and I won't be able to manipulate this algebraically to make it say 1 minus tangent squared. Okay, so whatever substitutions you make sure that they are, in fact, valid. So I don't have any identities that I can really fall back on. But what I do notice is, well, I still have, the one, trick in our tool bag that we, kind of our last ditch effort, which is, well, maybe I'll turn everything into terms of sine and cosine. So let's do that. Secant is really the reciprocal of cosine, so secant squared is really 1 over cosine squared u. I just have 1 here, minus, well, tangent squared is really sine squared u over cosine squared u. So sine squared u over cosine squared u. So let's see if that does anything for me. So I turn this expression into everything in terms of sine and cosine. Well now, I have this minus this fraction, so it'd probably be in my best interest to at least make common denominators here. So the common denominator would be cosine squared u. So 1, I can rewrite that as cosine squared u over cosine squared u. So on top of this fraction, I still have 1 over cosine squared u. In the denominator, I have 1 minus, sorry, not 1, but cosine squared u minus sine squared u over cosine squared u. I'll write that in a couple pieces just so you're clear. So this 1 is going to become cosine squared u over cosine squared u minus sine squared u over cosine squared u. Oops, I already have the equal sign. And now I can combine these into one fraction. This is really 1 over cosine squared u over, if I write that as one fraction, it's cosine squared u minus sine squared u over cosine squared u. I'm running out of board space here, but I'll try to squeeze it in here. I have a fraction divided by a fraction. Well, if I have a fraction divided by a fraction, that's the same thing as multiplying by the reciprocal. 1 over cosine squared u times cosine squared u over cosine squared u minus sine squared u. So I have this fraction divided by this fraction. So I'm just taking this fraction and multiplying by the reciprocal of that. And these factors cancel out. And what do I have left? I have 1 over cosine squared u minus sine squared u. That's what I was trying to get. So lucky us, right when I ran out of board space, that's when we also happened to run out of steps to do. Okay, so that's where I'm going to end this video. Look on Aries. Once this uploads to YouTube, I'll put on Aries a corresponding assignment. I'm just going to assign you again some more of these. And then tomorrow we may or may not move on to the next section. I'll see what's left in this section if there's anything I feel that we may still want to practice. Otherwise, we may be moving on to the next section. When you see the next video, obviously you'll know which way I decided to go with that. Okay, have a good day.